And thank you, Matt and FirstMark team for having us here. So I wanted to talk a little bit about IoT and what it means and how we might think a little bit differently about it in the future. So my first slide is this, which is perhaps obvious, but what is IoT really? And I've, over the years, we started this company 4 years ago, and I've really come to hate this term. Like I don't know what it means to some extent. I have some ideas about what it might mean. But I think it adds general confusion to what is a pretty straightforward proposition, which is like, how do you make it more cost effective, and in some cases possible to like extract data out of the physical world in situations where it was challenging previously. And ultimately do something useful with that data. Although I would argue that last part is not really a specific thing related to IoT as much as it's sort of a big data BI thing that we've been doing for a long time. But there are other things about IoT that are very specific and different to big data and BI. And when you're dealing with practical resources like battery life and low power devices, you have to sometimes do things a little bit differently. And controlling things, which is sort of an interesting topic, is not something that we've seen, I think, exploited to the extent that it could be. But really, the main thing that I think we've gained by sort of attaching a name to this whole space is that we have actually like helped businesses think about what to do with sensing. And I think, you know, if you don't attach a big data or an ML or an AI or something like that, I think that education curve is a little bit slower. So there's been some benefit to calling it IoT, but ultimately I think it's just about gathering data from the world and perhaps controlling it at the same time. And so I think this not a one-size-fits-all thing is a really important point to sort of address in IoT. It's not really a one-size-fits-all problem in the same way that you wouldn't think of like, what's an internet solution, right? You don't think of a database as an internet solution. You don't think of Facebook as an internet solution. These are not really, it just doesn't really work that way. And so I think as a result of like just trying to describe something in a sort of incorrect way almost, you've ended up with a lot of companies and money and time spent trying to solve problems that don't really exist. So I don't really know what an IoT database is, right? Or how it's different from any traditional time series database, or why you couldn't just use Postgres for that, frankly, right? I'm not sure how that's different. And especially now that we've, over time, started to see first-class support go into some of these major cloud providers like AWS and Azure. Is it Azure or Azure, by the way? We call it Azure, so I'm not sure. We'll just call it Azure. Azure? All right, we'll call it Azure. So, but now the AWS and Azure and Google Cloud have started to like have some type of first-class support for IoT. It's starting to change what it means to be an IoT platform, because shockingly, these guys are actually really, really good at this. And their IoT platforms are really, really good. So apologies to any IoT database guys in the crowd. I didn't mean to offend you. Vertical focus is something that I think has been an interesting thing to observe in IoT. There's some really, really good and excellent companies solving really, really good problems in the IoT space. And they're doing it in a very, very vertical way. So if I thought of people like Samsara or C3 or Sight Machine or guys like that, these guys are actually adding a tremendous amount of value to their customers, and they're doing it in a very specific way, and they're solving a very specific set of problems. And this is obviously a stark contrast to the group of people, perhaps including us, that I mentioned that are sort of on the IoT platform in a sort of more horizontal way. And I think ultimately we need a lot more Samsaras and Sight Machines in the world to really prove this sort of hypothesis that IoT has any value whatsoever, right? Like, is the notion of sensing things actually leading to safety, efficiency, quality, customer satisfaction, and ultimately ROI, or not? And we're not going to get there with just a bunch of horizontal stuff. So these companies like this, I think, are solving really good problems. But there are real challenges for these companies in actually doing this. And so I think we've seen a lot of, in my opinion at least, seen a lot of companies be pretty lazy about what IoT means. They've often said, like, just give us the data and somehow we'll do something useful with it. And that's a cool story. Like, I wish it was as simple as just like, how do I deliver the data to you? But how exactly do you do that, right? Especially when you're dealing with like resource-constrained devices that need to be wireless, battery-powered, for example. And what if you don't want to rely on the customer's Wi-Fi, or there's no cell service, or the device needs to cost $1, or at least last several years on batteries? Right? These are like actual, practical, very, very difficult problems to solve. And if you're not using those technologies like Wi-Fi, cell, or Bluetooth, like what are you using to actually connect those things? And there's a bunch of stuff out there. There's LoRa, and there's Sigfox, and there's RPMA, and there's all sorts of technologies out there. But I will say that those things are still far too hard to use. Like I have an entire drawer of stuff at my office that is like several feet deep of just development kits from other companies. And I don't understand why it's as difficult as it is. You know, coming from a software background, we sort of expect things to be relatively straightforward at this point, right? If you're building a web application, you're not expected to understand how TCP works anymore. And building IoT devices, I think, should be roughly the same. And so security is like one of the most talked about subjects in IoT. I think it's pretty well understood that it sucks. And there's certainly been some like sloppiness that has resulted in like some of these security issues. If you looked at like the way the Mirai botnet worked, which was one of the most high-profile ones that took down like DNS infrastructure in the States especially, like that was literally like devices that had open ports and a combination of usernames and passwords that everyone knew. And it's like that's sort of a shocking state of affairs that that's still how we're doing things. And then there's a bunch of IoT development platforms out there that still have like unsigned firmware mechanisms. And I don't understand how this is the way it is. But part of the answer is that it's really, really difficult to secure embedded connected things. And part of the answer is there are not enough service providers like helping with those problems, right? If you're left to your own devices, you're probably going to screw that up, right? Because your value proposition is really not about building like low-level embedded security. Your value proposition is whatever your product does, like being a thermostat or whatever, right? It's not about being a security expert. And when you're dealing with these embedded devices that have microcontrollers, like MCUs as we call them, you don't really have access to like traditional things that we take for granted, right? You don't have Linux and BSD, and you don't get to take advantage of TLS and TCP/IP and things like that as a result, right? You've got to sort of figure this out on your own. And what most people end up doing is just not figuring it out, right? They just sort of leave it alone, or they make sort of ambiguous claims that this should just be done at the application level. And that's a sort of dangerous position, I think, for the industry to be in, and why I think you've seen some of the security problems that we've seen. So I think ultimately, like IoT, as far as I'm concerned, and why Helium exists, is about how do we create more success stories in the space, right? That if you looked at the Samsaras and the Sight Machines and the C3s of the world, they've been extraordinarily successful despite the problems, as far as I'm concerned, right? They've like sort of trudged through the issues and they figured out ways to do it themselves. But in most cases, like I don't think IoT has gotten like quite as big as everyone thought it would be, right? It was supposed to be like, I think by now Gartner estimated it was supposed to be bigger than the US economy. And I don't think it, at least as far as I'm concerned, it has not occurred. So we're not that big yet. And in some cases, or a lot of cases, you've got companies like, I don't know, the two-letter acronym company that's big, that just reclassified existing products and started calling those revenues IoT. Right, and I don't think that actually helps the industry because it's sort of like inflating this thing that isn't really real yet. And so I think ultimately what IoT needs is, it needs tooling, right? It needs things like LAMP in the early days, AWS in more recent history, Rails, Node, Xcode. I think what those things did for web and mobile is that they enabled people who weren't even necessarily considering themselves as engineers to build things, right? And you got this explosive environment of people building apps. And some of them were ridiculous. Like if you remember in the early days, there was the I Am Rich app on the iPhone. I don't know if you remember that thing. It was kind of awesome. But you got people that didn't really think of themselves as engineers just being able to build stuff all of a sudden, right? And IoT doesn't have this. Like you're still supposed to be an expert in embedded technology and wireless and power consumption and security and all the underlying things in order to do that. And so even though there's been a bunch of money into things like LoRa and Sigfox and RPMA, it's just a piece of the puzzle, right? It's still very, very complicated to like build a complete working solution. And there's a lot of compatibility issues that come along with this. And ultimately what you end up with, I mean, I know I just said don't trust Gartner because they said it's supposed to be as big as the US economy, but their estimate is that 74% of like IoT projects end up failing because they're over budget, they're over time, they're just far too complicated to get off the ground. It's very, very difficult to just get a prototype working of some sort. So I think to help this industry and like really do good things in the IoT space, we need to solve the underlying problems that cause these IoT projects to fail. And ultimately like enable more Samsaras and Sight Machines and people like that, and the speakers who are before me, who are really good at things like customer experience and data science and visualization, and ultimately delivering ROI for their customers. And they shouldn't have to like be experts at the rest of the stuff. It needs to be an order of magnitude easier, like at least an order of magnitude easier to do all of the things that you have to do to bring an IoT project online. It's still like fairly challenging to even pick what you want to use in terms of hardware and wireless. And then once you do, it's actually difficult to do anything with it. Like I spend particularly like an extraordinary amount of time experimenting with some of the technologies in the space, and it takes, I can't even explain to you how many hours I spend like trying to get other people's things to work. And I don't think it should be like that, and arguably there are not that many people as stupid as I am that are going to spend that amount of time on the problem. So I think we're leaving a lot of untapped potential on the table by making it as complicated as it is, and people who can and will do excellent things are just not able to do it because it's too complicated. So I think we need to solve multiple things, which are the network coverage level, like how do you just get sort of ubiquitous access to network coverage the same way you do with cell? The hardware level, like how do you make hardware significantly easier than it is today and more like software? And that extends into firmware, like why would you think of firmware any differently from software, for example? Like why is that even a differentiation? And then ultimately what the software and the cloud level looks like to the extent that it should just not be a thing that you have to think about. And part of, I think, what we're missing out on is what I try to describe as like new types of marketplace. Because it's just so hard to get anything to work in the first place, you don't see a lot of people experimenting with what I would think of as very interesting and novel ways of doing things. I think there's a whole new economy of machine-to-machine and autonomous payments that can exist around not only the value of the connectivity and coverage, but also the data that comes off those networks. And that should be very, very different, I think, than just charging people dollars per megabyte the way a current cell carrier does, right? I don't think that's actually a model that can sustain itself or work. But again, because it's so difficult to tie all this stuff together, you're not seeing much of this development happen and not many interesting use cases here. And I think there's a whole world of things that will be enabled here. You could almost imagine like some sort of gig economy where people are just putting sensors all over the place because someone else finds that data valuable, whether it's foot traffic or radiation data, whatever it may be. You could imagine what that world might look like if there was enough infrastructure underneath that made that easy enough. And so one other like major problem beyond it just being like extraordinarily difficult to use any of this stuff, is that nearly everything out there, at least in the LPWAN or the wireless space, is proprietary in nature or controlled by a single vendor. And I'm almost certain, I can predict already that Semtech is going to tell me the LoRaWAN Alliance is a very open thing. And it kind of is, right, half. And the difference between a lot of these technologies is extremely nuanced, right? The difference for a non-expert between RPMA, LoRa, Sigfox, Helium, and anyone else I could rattle off is not something that I think most people would understand or should need to understand. So our belief at Helium, and I'm trying not to talk too much about Helium today, is that we should be using non-proprietary and decentralized tech basically everywhere we can. And the stuff is good enough at this point that there really is no reason to have any proprietary levels of the stack as far as we're concerned. And we've done a ton of testing around this. And if you think about like sort of historically what things looked like, even in the web world, if you thought about something like Cold Fusion in the mid-90s, if everyone remembers that horror show, once the open source stack caught up to that, like those guys were toast, right? There was like absolutely no reason to continue using Cold Fusion and paying the server licensing fees. And I think it will be like this in IoT. And I'm not sure that we need another CDMA Qualcomm thing anymore. Like I think we're over that and we shouldn't have to deal with that. And even if you just thought about from a practical perspective, what Wi-Fi looks like today, right? In a building like this or a building like our office in San Francisco, there are hundreds or thousands of Wi-Fi access points, all competing for the exact same piece of spectrum on the exact same set of channels. And it means that everyone ultimately has a pretty shitty experience, right? And so if you could have some sort of cooperative networking around this stuff, I think everyone's life would be a whole lot better. And so the big clock is staring at me with 1 minute to go, so I'll try and hurry through this part. I don't want to talk too much about Helium, but it's not hugely surprising that I will. And it's also not hugely surprising that I think what we're trying to do at Helium is try and solve all these problems, which is how do we make network coverage using commodity components that is decentralized, that has a mechanism for autonomous payments, that has cryptographic location built into it, and most importantly, perhaps, has excellent tooling around how you might use all of that. We think that would like deeply and strongly since we started the company that if we made all of this significantly easier to use, everyone or more people would build IoT things that were highly valuable. And we think we haven't seen that yet because it's still just a little bit too hard to use. And it requires like a lot of thought and a lot of expertise at like multiple levels of the stack that no one should really have to deal with. And so we'll have a bunch of announcements in the near future about some of the interesting things that we're doing. But in the meantime, our current gen of products actually is really, really good. at building highly secure, low-power connected things and giving them a way to route data from device to the cloud, whatever that may be that you want to use. And so, of course, you should go and buy them immediately. So that's it. The clock has reached 0. So thanks for listening. I wanted to see if there's any questions. Do you like that? I hit it exactly at 0. You saw that?
I was not expecting anything less from you. Thanks for the great presentation and the pictures on the slides.
Let's keep it simple. Yeah.
Do you have questions? One over there from Drew.
By the way, my mouth is still burning from the button thing. By the way, it was
great talk.
Pretty awesome.
Just one thing I was curious about is, do you see any positive role of a regulatory regime in bringing any sort of answers to the questions that you posed?
Say that first part
Any
again?
positive role for regulator, government, international regulators?
Quick answer is no. I think, and perhaps I'm too libertarian in my views here for the average crowd, but I think wherever regulation is involved, you end up with sort of artificial marketplaces. Controversial point of view, I know. And I think we're seeing that already with things like LoRa and Sigfox and RPMA and guys like that. It's not a regulatory thing that's driving that. But this notion of the need for multiple proprietary closed source things that roughly do the same thing, I think is very harmful. And ultimately, I think we will see, as we did with the web world, for example, where I think ultimately the LAMP stack is what killed off Macromedia and all of the terrible technologies that they had at that time. I think the same thing will happen here, and I don't think regulation is the thing that should drive that.
Do you want to talk about quickly, actually, about what LoRa actually is? I mean, this is, a mixed group. Some people love IoT, some people love VR. So maybe just to paint a high level of, connectivity options from, Bluetooth to Wi-Fi to cell. Sure.
Yeah. So I made a lot of assumptions there that everyone understands the text the way that I do. So it's a good point. So LoRa is a very interesting piece of technology that was originally developed by a small company in France and acquired by a company in San Jose called Semtech. LoRa ultimately is an interesting modulation scheme, right? So they use something called chirp spread spectrum, which is a sort of an interesting way of sending data over RF effectively. The thing about LoRa there are many things about LoRa that I think are a little bit challenging, but the most challenging thing is that only Semtech makes LoRa hardware. They own the rights to that. They are the only manufacturer. They've started to license it to a couple of others. But that inherently, I think, is a little bit challenging. And the interesting thing about LoRa is some of the range and what they've been able to do with wide coverage areas. So you've got companies like Orange and now Comcast and people like that are deploying LoRa networks because of the range that they can get. I think ultimately what they're getting out of LoRa, because there's a standard on top of LoRa called LoRaWAN, which is the networking layer that lives on top of LoRa, the technology. Building or thinking about how to build networks on top of just raw technology is actually a very challenging and complicated problem. And so one of the nice things that you get out of LoRa and LoRaWAN is that someone's already thought of that problem, right? Like, what does it look like for a device to join a network? How do keys get transferred? What does over-the-air updates look like? Well, they haven't addressed that quite yet. But how does the whole system work, right? Just beyond the actual, like, it's a cool piece of modulation. And so I think that's actually a very valuable problem that they've solved there. And Sigfox has done a similar thing, except they've done it in the reverse way, where Semtech has said, LoRa is ours, the chips are ours, we own the chips. Sigfox has actually used a bunch of open standard technologies, but they control the network themselves, right? So they've built the network coverage themselves, they've installed gateways all across countries, and they control access to the network. So you sort of have this reverse thing where Semtech is all about the chips and Sigfox is all about the network. And ultimately, I don't think it's ideal for anyone, and there's a bunch of like technology limitations that come with that I can get into tremendous detail about if we have time. But that's effectively the LP WAN space is effectively Sigfox, LoRa, and there's another technology called RPMA, which is developed by a company called Ingenu in San Diego, which is ex-Qualcomm guys. And then on the other side, you've got technologies that you guys are I'm sure, extremely familiar with, like Wi-Fi and Bluetooth and cell.
Great. Yeah, one question here
So how is it different? Like if you're going to build a device out of, say, an ARM chip, and I'm going to buy it, that device is made by one company. So what if Semtech owns the chips? They provide a good value. Like, I'm not sure I understand your problem with it being closed when they own that technology.
Yeah, no, it's a good question. So there's a sort of philosophical point of view there, where it's just like it shouldn't be closed, but that's not valid in a world where people need to make money. The real problem is that you start, at least in my opinion, you start to get these sort of artificial points of leverage. And some of, I can't go into like a tremendous amount of detail because some of it is not for public consumption. But some of what Semtech is now trying to do in terms of where they think about value being generated with LoRa is beyond just chips, right? They're now trying to sort of insert themselves in the process and say, okay, if you want service X, Y, or Z, you need to start sort of paying us money for that, differently from just buying chips. And maybe that's fine. There's a perspective where saying, like, you guys built the technology, you own it, it's yours, like, fine. But the other point of view there is that the problem that they're solving is actually solvable a completely different way. And that's my biggest issue with it, or not really issue, but the biggest solution I think that can be derived from that is that there's a way to do exactly what LoRa and Sigfox and RPMA and those guys do that is built on a completely open stack, right? There doesn't need to be any proprietary components anywhere there in order for that to work. And we weren't sure that that was true for a while, and we spent a lot of time like evaluating. That's why I have the drawer of shame, right? I have like every dev kit from every like company that ever existed. But we're now confident that you no longer need any proprietary pieces to recreate effectively what LoRa does and what Sigfox does. The challenge is that someone needs to design that whole system, right? Like the design of how it all works, how keys are exchanged, how devices come online, how they associate, how they get blacklisted, like all of that needs to be created by someone. And I think that's where the hard work is, and that's ultimately what we're trying to solve. And we think we can do it in a way that gives people a lot of choice in terms of what hardware they want to use, what software they want to use, and ultimately delivers roughly the same thing and perhaps in some cases better. Hope that's a decent answer.
All right, very nicely done. Thank
Cool.
you so much.
Thank you.